Okay, I just did a test, and here's what I got. 16 spaces is one 36-degree cycle. Let me turn it on here, and I'm going to try to do this really quick. Not bore everybody. Okay, this is 120 volts coming in. Look what we got. 102 volts across 450 ohm resistor. This is the output. So it's 102 volts times 100. We have 23.1 watt output. You can do the math if you want. Now the input is 120 volts. We know that for sure. Times 0.24 is 28.8 volt amps. It's not watts because you have to do the power factor because there's a big phase shift. And I've calculated the power factor is 0.382, so it's 11 watts input, 23 watts output. Let's look at the phase shift. The phase shift is what makes this over unity. Now, you don't have power unless you have overlapping voltage and amps. So the real power is only this triangle area right here because it's overlapping there. Here's the zero line and that triangle. That's really all the power you see. We're looking at the input here. And here's the phase shift. Right here and right here. See that? See the way? This is the voltage, the high one. Voltage is leading the current. And the current shoved over this way, or you can say the voltage is shoved over this way. Now, measuring that gap right there is one way to do it. Like another way is you go up to the peaks and you go the peak here and the peak here. But look how I'm doing it. It's much better, I think. I take a clear piece of plastic and I go right down the middle of the phase I'm measuring. This is the voltage phase right down there, right down the middle. Which you see, it's quite a bit off of where the peak is. Pretend like you're dividing a piece of meat. Two starving people. And if you don't divide it right in half, you'll die. So get it like right in half, so it's the same area both sides. And then look at where it is. And then do the other one too, and count the spaces in between here. And I get 3 when I do it here. So, knowing that's 3 spaces, first of all you go like a full cycle, 16 spaces. I don't need to show you that, but that's what it is. So it's 22.5 every space. So you have 3. Look at the phase angle. It's a big phase angle. And that brings a cosine of 0.382, and that's what the power factor is. So at the end of the equation, you get to times 0.382, and that brings it down 11 watts. So here's a picture I made. So you can see how this is. If you did it here, boy, that doesn't work very good. If you did it where the peak is, I wonder if scopes, when they calculate the phase angle, if they go off the peak. I don't know if they can do this, but you see really it's about right here. the middle of it, from here to here, exactly in the middle. It's over this way more to the left. So that's what I'm doing. So I'm making a phase angle, manipulating these numbers all I can, trying to get them real. So just want to say all that. Let's look at the amps. 0.02 square division. That means every space is 0.004 volts. Let's pull the, here's the amperage. Let's pull it up here. Right on that top one. Anyways, looks about 18.5. And the volts we know is 120. Okay, when I did this 10 minutes ago, I had amperage at 17. Now I have amperage at 18.5. So I redid the amperage for the input, and I got 11.9 watts with the power factor of 0.382. So whatever, so it's either 12 watts in or 11 watts in and 23 watts out. Thanks to measuring the phase angle and figuring the power factor. If you did just meters, it would just read the amps and the volts. So, okay, well, there's a video. Thanks for watching.